Hello students, how are you all? In the previous class we have discussed about the hybridization trick, right? So in that previous video we have covered the hybridization trick for the neutral molecules like ammonia and CH4 methane. This is the BH3 boron. See, if you look at these three molecules, there is no charge over the molecule, right? So for this molecule we have studied the hybridization trick. It is very easy. You can check my previous videos. If for example, if you have any of the molecule, if that possesses like a positive charge or a negative charge, how we have to evaluate the hybridization in case of charge is there on the molecule. That's what we are going to study in this video. See, this is the formula which we are going to use to find out the hybridization. What is the total number of orbitals equals to number of sigma bond plus number of lone pairs. Okay, what is number of sigma bonds, what is number of lone pairs, you will understand by doing the examples. Okay, so this is what our example NH4 plus. Okay, so to find out the NH4 plus hybridization, first we should know the valency of nitrogen, that is 3, and valency of hydrogen, that is 1. Okay, and then we should know the central atom. Among this, in this molecule we have two types of atoms, one is the nitrogen atom, one is hydrogen atom. So in which two atoms, which is central atom, so that how will you evaluate? Nitrogen valence is 3, hydrogen valence is 1. Which is having more valency, that is the central atom. So first write the central atom. Right. Next, what is the group number of nitrogen? The group number of nitrogen is 50. That means you should write first 5 electrons. And then we have positive charge over the nitrogen. So as we have positive charge over the nitrogen, we should remove 1 electron from this. Out of this 5 electron, we should remove 1 electron. Okay, so just remove 1 electron. And then, and as hydrogen valence is 1, so it connect with 1 electron of nitrogen with 1 electron of hydrogen. Okay, so as we have 4 hydrogen atoms in this ion, so 4 electrons pair up with 4 hydrogen atoms. 4 hydrogen atoms. Now these all are single bonds, right? So in the beginning I mentioned in the previous video that all single bonds are sigma bonds. So you can also see this statement, all single bonds are sigma bonds. So now you can use the formula, that is total number of orbitals is equal total number of sigma bonds plus number of lone pairs. So here we don't have any lone pairs. If you find 2 electrons extra without pairing of any of the atoms in the given molecule, that will be considered as a lone pair, but we don't have extra electrons. So according to formula, total number of orbitals is equal to total number of orbitals is equal to number of sigma bonds. Here all single bonds are sigma bonds I mentioned. So sigma, sigma, sigma. 4 sigma bonds are there. So 4 sigmas plus, is there any lone pairs? There is no extra electrons. For each 2 extra electrons, 1 lone pair you should take. So there is no extra electrons. Hence you should write 0 lone pairs. And what is the total figure? 4 plus 0, it is 4. When you get total number of orbitals 4, so what is that total number of orbitals 4? So that is equal to, what is the hybridization, that is sp3 hybridization. So NH4 plus, it undergoes, what is that hybridization? sp3 hybridization with 0 lone pairs. Next example, BH4 minus. So hybridization of this BH4 minus ion is, so first what we have to do, we have to select the central atom. We have two types of atom. One is a boron atom and another one is a hydrogen atom. So among these two we have to find out the central atom first. So here the boron valence is 3 and hydrogen valence is 1. So where the valence is more, that is the central atom. So first write the central atom. And central atom group number is what? Boron is the third A group element. So should write 3 electrons. Now we have minus charge over the boron. So minus means gaining of electron. Positive means loss of electrons. So as we have minus, it is electron gained by the boron atom. So you should write 1 electron extra, as boron gained 1 electron by getting minus charge over. Okay. So 4 electron you have written. Now pair up with the 4 hydrogen atom. We have 4 hydrogens, right? So each hydrogen valence is 1. So only 1 electron from the boron it takes. So it forms 1 sigma bond. And another hydrogen take 1 electron from boron and form sigma bond. Similarly other hydrogen. So 4 hydrogen they connected with 4 electrons of B minus ion and formed 4 sigma bonds. So this is 1 sigma bond, sigma bond, sigma bond, sigma bond. No extra electrons. So there is no lone pair chance. Now go for the formula. Total number of orbitals is equal to, what is that? Total number of orbitals is equal to number of sigma bonds. We have 4 sigma bonds. So 4 sigma plus we don't have any extra lone pairs. So 0 lone pairs. LP stands for lone pairs. So 4 plus 0, 0. Finally 4. Total number of orbitals we got 4. Total number of orbitals 4 means what is the hybridization? Again it is sp3 hybridization. That means BH4 minus it undergoes sp3 hybridization. It is very simple. You can apply for any of the charged particles, whether it is charged molecule, whether it is a negative charge or positive charge. Next example is CO3 minus 2 carbonate ion. In this we have minus 2 charge. So minus 2 charge means 2 electrons extra we have to add. Okay. So first we have to select the central atom. Here we have two kind of atoms. One is a carbon atom, one is a oxygen atom. Which one is central atom? Go for the valency. Carbon valence is 4, oxygen valence is 2. So where the valence is more, that is the central atom. So write the first central atom. And what is the group number of carbon? It is a 4th A group element. So write 4 electrons immediately. And then what is the charge here? Minus charge. That means addition of electrons. So total charge is what? Minus 2. So 2 electrons you need to add extra 2. That's over. Then here the other atom is there now. That atom valence is what? 2. That means it connects with 2 electrons of carbon atom. So 2 electrons. This is the 1 electron. This is the 1 electron. So oxygen connected. And then we have 3 oxygen atoms, right? Hence there is other 2 electrons of the carbon and connected with the oxygen. As the oxygen valence is 2, it is connected with only 2 electrons. And the other 2 electrons, 1 oxygen atom. Total we have 3 oxygen atoms, so 3 are over. Then what is the next step? First we have to select the number of sigma bonds, number of lone pairs. So here we have 2 bonds for oxygen atom. Earlier I mentioned that each single bond is a sigma bond, but here we have not single bond, double bond we have. So in any of the multiple bonds, whether double bond or triple bond, one is a sigma bond, remaining all are pi bonds. So this is the sigma bond and this is pi. This is sigma bond, this is pi bond. For this oxygen, this is sigma bond, this is pi bond. But in our formula, we have only number of sigma bonds. Total number of orbitals is equal to, what is that? Number of sigma bonds. This is a 1 sigma, 1 sigma, 1 sigma. Total 3 sigmas are there. Is there any extra lone pairs? There is no lone pairs. Hence 0 lone pairs. Total what is that? 3 plus 0, that is 3. So total number of orbitals 3 means, what is the hybridization here? Total number of orbitals 3 means, that is sp2 hybridization. So hybridization of this carbonate ion is sp2. What is that? sp2 hybridization. Students, if you find this video is helpful, please like and share with your friends and classmates. Subscribe it. Thank you for watching.